All right, so for question 18, we are asked to describe the shape, center, and spread for the dot plot shown below. Remember, when we talk about center, that's going to be most likely mean or median. When we talk about shape, we could talk about skew, or if it's symmetric, uniform, bimodal, etc. Spread could be either standard deviation, interquartile range, or range. And we don't have to address all three of those. So for number 18, when I look at the shape of this data, I see a big like kind of cluster of data here, but then some data out here that kind of tapers off. So I'm going to say that the shape is that this data is skewed right. So when we see this kind of tail, like we've got some data out here that's that skew is going to pull our mean in that direction. We could say that data is skewed right. Okay, if we're going to discuss the center of the data, we can find the mean from a box plot, but let's just look at the median. So I don't know how much data we have, but here's the quick trick for finding the center. I'm going to start, hold on. Sorry, I keep getting interrupted by the drill that happened this morning. Okay, so if we're trying to find the median, what we could do is just count our way in from the left and the right. So for example, when I look at 0 and I see 1, 2, 3, 4 dots there, I know that is 4 zeros in my data. I could also list them out. So I could say my data has 1, 2, 3, 4 zeros. 1, 2, 3, 4, 5 ones. So 1, 2, 3, 4, 5. Oh, it looks like we've got 5, 6, 7, 8 twos. So I could list out all of my data and find the center, or I could use kind of like the cross out method, that if I think, okay, if I cross out 1, 2, 3, 4 of my lowest number of data, like zeros, I could start at the highest end, cross out 1, 2, 3, 4. Then I might go in for more. So 1, 2, 3, 4. Over here, 1, 2, 3, 4. Oh, we can see what our median is going to be right now. Because if I cross out like one more here and one more here, all I'm left with in the middle are twos. So it doesn't really matter which one of those dots is in the exact center. We could tell that our median is going to be 2. Oops, median. So our median of the data set is 2, and for us to find the mean, we would have to add up all these numbers and divide by the number of data. So we can, but we don't really have to. The spread of our data, probably the easiest thing to address here would be the range. So since my max is 10, my minimum is 0, that means my range is 10. You could find the interquartile range if you wanted to, but we could quickly, easily describe the range. We would need to, we don't know how to find the standard deviation by hand. It's not hard. If you're curious, you could look up how to do that online, or I'd be happy to show you. But if we're not given the standard deviation, I'm not really expecting you to talk about it unless you do find it. So, all right, question 12, write 2 sentences. Write 2 sentences, one to compare the centers and one to compare the spreads of the 2 data sets represented below. So remember, in a histogram, I like how colorful this is on my computer. I know yours printed in grayscale, but in a histogram, I can't tell what my exact median is. I can just tell where, like what bin it falls into. So if I'm looking at my histogram, I could see that this height, I don't know, that height looks like maybe it's about like 4 on my axis. The age group from 6 to 10, that looks like that might be around like less than 30, maybe around like 27 people there. The age group from 11 to 15, that looks like pretty close to like 44, 45. Not really sure. This one, 16 to 20, that age group looks like it's maybe 51 to 52. Let's see, we've got maybe like a 36 here. And I'm just kind of ballparking this. This looks like about 27 as well. So if I'm just trying to determine where the middle of my data is, what bin it would be in, if I were to add these numbers together, I get, I don't know, 60 something, like 63. And if we were to add these numbers together, we get in the 60s as well. So like all that to say, like this bin is definitely where the middle of our data lies, because we have 15, about 51 like people in that bin, and roughly 60 something on either side. Like that's just a rough estimate. So we could tell that our median is going to be in this bin. I don't know exactly how old, like the age of the person who is the median, but we know that the number is going to be between 16 and 20, because that's what it says down here. So the median age of people in this survey who said M&Ms was their favorite candy is going to be somewhere between 16 and 20. We don't know exactly what it is. And then again, for like the range, because we weren't given a standard deviation, we could only ballpark the range. So our range is like, if my min was 0 and my max was 30, the maximum our range could be is 30. But remember, I don't think infants who are 0 years old eat M&Ms or could answer whether or not they're their favorite candy. So I doubt the minimum age is really 0. Like, who's giving a baby M&Ms? That's a choking hazard. Bad parenting. So we could also assume that maybe the minimum is actually 5. And who knows, maybe the maximum age was actually 26. Like, we can't tell that from a histogram. So if I did 26 minus 5, that would be 21. So our range is somewhere between 21 and 30. We can't tell exactly what it is. Okay, over here, if we're looking at centers, well, we know our median is 60. That one is easy. We know the middle 50% of our data, we could eyeball it, or we could guess that our range is, I'm just thinking maybe this is like 67 over here. Maybe this is like, I don't know, I'm just kind of ballparking it. Maybe this is like 52. So it looks like our range is around 15. So like maybe a little bit less spread. Okay, we don't need the exact range to be able to write a comparison statement. So when we compare the centers, we could say like the median age of people who like M&Ms, or I guess more specifically that's their favorite candy, is around 16 to 20. Now, I don't know. Oh, this is amount of Skittles per bag. This is weird data to compare. These are not the same types of data. One's about how many Skittles are in a bag. One's about who likes M&Ms, whatever. So the median age of people who like M&Ms is around 16 to 20. And also, when have you ever had 60 Skittles in a bag? The median number of Skittles in a bag. Wow. Is 60. So the median of the Skittles is greater than the median of the age of people who said M&Ms is their favorite candy. That just seems like an arbitrary comparison, because one's about preference and one's about number of Skittles. When we compare the spreads, we might just say that the range, that like there is a greater age range in the M&M distribution than the Skittles distribution. So I'm looking at the actual range for that. All right. Those two are good enough for me. Usually we would compare like different data that's kind of the same thing, like how many M&Ms in a bag versus how many Skittles in a bag. But whatever, I did not make this review, and I'm just happy that it's here for us. All right, have a good one.